In this episode, I would like to talk about the hydraulic circuit that I have designed for this mobile robotic platform. Um, if when you are designing a hydraulic platform, you have to think about many options, many things. The most important thing is that what is the application of this hydraulic power system? Specifically for this one that I have considered, it's a mobile platform that needs to lift up all the weight and using omni wheels just move around on the factory floor, and it could like carry robots or the equipments regarding to the hydraulic system itself, and also uh, probably electrical cabinets. It could also carry some tools. So considering this into your mind, I go through some defining some options, hydraulic equations, and also some important equations that you should consider when you're designing a hydraulic system. So let's review these accessories and components together. All right. I would like to a little bit introduce you the this software so-called Choose. It's from Bosch Rexroth, and it has been produced with the cooperation of Automation Studio company that is a famous one for simulating the hydraulic circuits. But this one is just, as you see, very simple version of that, and it's actually free, and you can easily download it from their website. But it has a very nice library of hydraulic components regarding mechanical valves, high pressure, and some cartridges and manifolds and some accessories that you can look for the components that you like and draw them in the whiteboard, and basically your favorite hydraulic circuit. Of course, it does not simulate anything. For that, you need more complicated software and probably paid software such as Automation Studio that I mentioned. But regarding the software itself, is very handy, very clean. As I said, is free. You don't have to pay anything, and you can basically draw whatever you like. All right, let's go back to our circuit, the hydraulic circuit that we designed for, in fact, the robotic platform. So in the view sections, there is the option of zoom in, zoom out, zoom in, and also the pan, which you can basically scroll around and see the whole um, diagram and drawing. And you see you can like write your name and the size and everything related to the circuit. I a little bit zoom out to be able to see the circuit, and yeah, so it's very handy. And in the design, you can also draw lines, write text, draw shapes or contours or rectangle. Some handy tools that you can use them, copy paste and etc. Uh, but what this is not what I want to talk about. It's more I want to explain what I have done for this hydraulic circuit. And so like any other hydraulics circuit, we need a power unit, and our power unit is by a pump, a fixed displacement pump, which draws fluid with a specific amount of rate, let's say, I don't know, 50 liter per minute, or something like that. And there's a tanker which is filled with hydraulic oil, and it goes through the yeah goes through a filter to remove the mm, mm, non-intentional things or extra particles in the oil. And then after the filtering, it goes to the pump. So this is the negative side of the pump, and this is the positive side of the pump. And the this side is the high pressure, which basically goes. This one is a kind of valve, and that it's so called, I think, check valve, that assure that there is no flow back to the pump. So it means that only there is one way, and always goes this way, the flow of the pump. Because when there is a possibility of the flow back, it could damage the pump. That's the reason that they put something like that. It reminds me actually like a mm, yeah rectifier, so something like that, that it makes the flow in one way. So it goes to this object. This one is let me zoom a little bit. This one is basically a directional valve. The directional valve, the main role of a directional valve is really easy. It just defines the path of the flow. Either it is forward or it is backward. But usually there is a definition or standard ID for each hydraulic pump. Usually, if it is actuated mechanically, you don't see such a things on the side. That is like, this one is like a contactor. But if it is only mechanical, you just see a spring. So when you see a spring and then something like that, it's a contactor, it means that it is actually electrically actuated. But it's not the case anyway. It's not so important. I just want to tell you that how it works. There's actually a spool inside a cylinder, that there are some holes, or let's say manifold, that the flow or the fluid can go through these yeah manifolds or holes. So it depends on the position of this spool. If the spool is in the middle, it means it is a neutral position. So whenever the flows comes and gets to to the valve, because the valve in it's in neutral position, it goes back. It goes back to the tank. But if one of these position to the left or to the right is selected, the shape of the or the path changes. Like, for example, if the left side of the valve is activated, this one could be a high pressure side, and this one the low pressure side. So the flow goes like that. But if this the right side of the valve is activated, it's opposite. It goes the right side is the high pressure side, and the left side is the low pressure side. So it depends that what is the positional request by electrical communicating or contacting. So let's imagine that this side is a high pressure, and it goes to several safety, I would say, valve here in the in between. And some of them are just for the safety issues. This one is a so-called, I guess, restrictor. It is important to have such a valve, because it will somehow, okay, the platform that we have is a like square platform, like flat platform, that lifts up the hydraulic system lifts up the whole platform on four base in fact wheels. So it's really important that all the wheels to be lifted, the platform to be lifted up from the foreside simultaneously with the same velocity and flow rate. So this one somehow regulates the speed, or how fast the platform will be lifted up. So it plays actually a very important role. Um, from the other side, we have the opposite side at the right side, as you see. This one exactly is that when the pressure changes and the flow, the path changes, and when the platform is actually sitting down, and it is also important that the platform does not drop. So we also need a regulator or a speed regulator with this restrictor or needle restrictors to control the flow rate. So, if we come to the front side, we have four-cylinder and pistons actually that they are activated both from both way, from up and from down and from up. So it depends that if you want to lift up the platform or if we want to just lift down, also bring it back to the, so it depends like which direction we are feeling the cylinder. And as I said, these are just more safety things. It's possible that, like, when the platform is lifting up, something collides or does not let the whole platform to be lifted up. So these are for the safeties that release the pressure, excessive pressure from the high pressure line to the tank, that it does not hurt someone or does not break anything. And yeah, I think that's it. Another important thing is this valve. This valve is very actually important and it's interesting because when we have exiting or when we have low pressure on the other side, or let's say when we are decreasing the level and it's going down, at this part we have low pressure. So what could happen if these sides get low, and we have a lack of fluid here? um, this might cause cavity, and cavity could happen when you have low pressure that creates vacuum inside the hydraulic systems. Therefore you need extra pressure to be added up to the lines, or extra flow, because otherwise it will create a huge gap or pressure gap that might lead damaging the hydraulic mechanical components. That's the reason we will consider such valve, which is again for safety and to like maintain the hydraulic system working properly in such extreme cases to avoid cavity. Yes, so I hope that you enjoyed this small introduction of the hydraulic system, which is implemented in this mobile hydraulic platform. And in the next, please review and read also on my blog, because in the web blog of the Dynamic Machine podcast, I have explained more, and there are some pictures and explanation and the models that you can find basically for this project. I hope you enjoyed it, guys. I keep you again updated. Really try to produce podcast episode as much as I can, but as I said, and I'm a full-time engineer, so I just do this in my spare time. This is my hobby, actually. Just like to like a little bit contribute in educating people in the field of machinery, automation, and yeah, these kind of things. I hope you enjoy it and see you next time. Bye.